Now we proceed to final three forms, namely infinite raised to 0, 0 raised to 0 and 1 raised to infinite. We will discuss all forms by example. Let us start with an example of 0 raised to 0 form. This is an example. Evaluate limit x tends to pi by 2 cos x raised to pi by 2 minus x. We have limit x tends to pi by 2 cos x raised to pi by 2 minus x. If we put x equal to pi by 2 here, cos pi by 2 is 0, so we get 0. Pi by 2 minus pi by 2 0, so we get 0 raised to 0 form. To evaluate this limit, we convert it into 0 by 0 form or infinite by infinite form. For that, we consider y equal to the given limit x tends to pi by 2 cos x raised to pi by 2 minus x. Now apply logarithm on both sides. We get log y equal to, according to one mathematical result, we can take log inside the limit. So limit x tends to pi by 2 log cos x to the power pi by 2 minus x. According to the property of logarithm, pi by 2 minus x comes to the multiplication. So we get limit x tends to pi by 2 minus x multiply by log cos x. Now we put x equal to pi by 2 here, pi by 2 minus pi by 2 0 multiply by cos pi by 2 is 0 log 0, that is infinite, so it is now 0 into infinite form. And as we have discussed earlier how to evaluate 0 into infinite form, we take one term in the denominator. If we take log cos x in the denominator, calculation will be difficult. So we take pi by 2 minus x in the denominator, so we get limit x tends to pi by 2 log cos x as it is in numerator divide by, take pi by 2 minus x in the denominator, 1 upon pi by 2 minus x. Now again we put x equal to pi by 2, cos pi by 2 is 0, log 0 is infinite, so we get infinite. And pi by 2 minus pi by 2 is 0, 1 upon 0 is infinite, so it is infinite by infinite form. To evaluate infinite by infinite form, we apply L'Hopital rule. We differentiate numerator and denominator, so we get limit x tends to pi by 2 differentiation of log x, that is 1 upon x, so differentiation of log cos x is 1 upon cos x multiply by differentiation of internal term, differentiation of cos x is minus sin x divide by differentiation of 1 upon x, that is minus 1 upon x square. According to that formula, differentiation of this is minus 1 upon pi by 2 minus x whole square multiply by differentiation of pi by 2 minus x, that is differentiation of pi by 2 is 0, differentiation of x is 1, 0 minus 1, that is minus 1. Let us simplify this expression. We get limit x tends to pi by 2 minus sin x upon cos x, that is minus tan x, pi by 2 minus x whole square goes to numerator, so pi by 2 minus x whole square divide by sin x upon cos x tan x goes to denominator, it will be cot x, minus minus plus, this minus remaining, so minus. Now we put x equal to pi by 2 minus pi by 2 0, so numerator is 0, cot pi by 2 is 0, so it is 0 by 0. So we get 0 by 0 form. Again apply L'Hopital rule. Limit x tends to pi by 2, differentiation of numerator 2 times pi by 2 minus x multiply by differentiation of pi by 2 minus x, that is minus 1, and differentiation of cot x, that is minus cos x square x. Now again we put x equal to pi by 2, x equal to pi by 2 minus pi by 2 0, numerator is 0. Cosec pi by 2 is 1 square, that is 1, so we get 0 divided by 1, that is 0. So we get answer of log y as 0. So log y equal to 0, but we consider this limit as y, so we find y. So y equal to e raised to 0, because we know that log y equal to x base e, so we get y equal to e raised to x. So according to that formula, log y equal to 0, y equal to e raised to 0, and that is 1. But y is the given limit, so this given limit we get as 1. So it is the procedure how to evaluate the limit, how to evaluate the indeterminate form 0 raised to 0.